Right now, KIC 8,462,852, the star they call Tabby Star, is still swallowing its own light. And scientists at NASA, Caltech, and Yale have no explanation, no model, and no way to stop it. But here's what nobody is telling you. The most unsettling data came in after we thought we understood the worst of it. It sits 1,480 light-years away in the constellation Cygnus. You cannot see it with your naked eye. But in 2015, NASA's Kepler telescope was scanning hundreds of thousands of stars, looking for the tiny, predictable dips of light that mark a planet crossing a sun. What it found at KIC 8,462,852 was not predictable. It was not tiny. The star was flickering, lurching, dimming by more than 22% in a single event. Named after astronomer Tabitha Bayesian, the researcher who first flagged the data as wrong, this star broke the algorithm designed to ignore noise, because this was not noise. Kepler had been built to find planets. It had never been trained to find this. Here is what a planet transit looks like. A smooth, symmetric dip, less than 1% and gone in hours. Predictable, clock-like. Tabby Star produces nothing like that. Its dips are jagged, asymmetric, irregular. They arrive without warning and leave without pattern. Some drop 20% of the star's light. Some last a week. Some have multiple peaks as if something enormous and structurally complex is passing in front of it. Not once. Not in a repeating orbit you could plot. Researchers mapped dozens of these events. No two were alike. Every model they tried, planetary debris, cometary fragments, interstellar clouds, failed to fit the data. Then astronomers went back to the archives. They pulled 100 years of photographic plates, old glass sky surveys taken before the space age. And they found something worse. Tabby Star has been slowly, continuously dimming since 1890. Whatever is blocking it has been there for over a century. And we only just noticed. But that's not even the part that worried them. The leading early explanation was a swarm of comets, thousands of them, broken apart, strung across the star's face in a loose, chaotic cloud. It sounded plausible. For about 18 months, it was the official best guess. Then the infrared data arrived. A comet swarm dense enough to block 22% of a star's light would be radiating enormous heat. The infrared telescopes would have seen it glowing. There was nothing. No heat signature, no warm debris field, no comet dust. Whatever was blocking Tabby Star was doing it cold, silent, and physically invisible except for the shadow it cast across a sun. And that is not how comets work. That is not how anything natural works. But here's the strange part. It shouldn't be possible at all. When researchers modeled what kind of structure could block that much light, that irregularly, without radiating heat, without following an orbit, only one candidate checked every box: a Dyson sphere. Or the partial construction of one, a megastructure built around a star to harvest its energy. The concept comes from physicist Freeman Dyson, a theoretical framework for a civilization millions of years ahead of us, wrapping its parent star in a shell of solar collectors. Astronomers at Yale ran the numbers. Dimming pattern, the irregular dips, the century-long fade, a partially built Dyson sphere in various stages of construction fits the observational data better than any natural explanation they have modeled. That is not a fringe theory. That was the conclusion from peer-reviewed research published in the monthly notices of the Royal Astronomical Society. In 2016, SETI trained its radio telescopes on Tabby Star and listened. And there was this, a faint, narrowband radio signal. Weak. Intermittent, not definitively artificial, but there. The follow-up observations went quiet. The signal was not confirmed. It was not ruled out. The file was closed without a conclusion. What this means is that one of the most closely watched objects in the sky has defied every natural explanation for over a decade, not because we haven't looked hard enough. Because we have looked with every instrument we have: Kepler, Spitzer, Swift, ground-based photometry networks, SETI arrays, and none of them have closed the case. The dimming is real. The irregularity is real. The century-long secular fade is real. The absence of heat where there should be heat is real. One of these facts alone would be a puzzle. All of them together point towards something our models were not built to contain. Either nature has produced a phenomenon documented nowhere else in the universe, or something made it. And if something made it, we have been watching it for 11 years without knowing what we are looking at. So here is the question that has no answer. If the dimming is not natural, if it never was, then what exactly have we been watching? And why, out of the 300 billion stars in our galaxy, did Kepler find this one first? Drop your best theory below. Because so far, no one else has cracked it.